Okay, so this is the second part of 9.2. We just talked about horizontal asymptotes. And so now we're going to bring in x-intercepts and y-intercepts that we've done way back a long time ago. And then we're going to put it all together with what we learned in 9.1 about vertical asymptotes and holes. So first of all, remember when you're finding an x-intercept, since an ordered pair for an x-intercept is going to be some x number comma 0, then in order to find the x-intercept, just let y equal 0 and see what you get for x. Vice versa, if you're trying to find the y-intercept, remember the ordered pair would be 0 comma some y number. So in this case, if you want to find the y-intercept, just let x equal 0. Now I am going to give you a little helpful hint. If you want to find x-intercepts and you have big ugly fractions like the ones we've been dealing with, well, yes, we're going to let y equal 0. But basically what that means is if I have the equation, let's say y equals x plus 2 over x minus 3. So if I let y equal 0, so that's like saying, oh, the whole fraction is going to equal to 0. Well, the only way a fraction can equal 0 is if you look at letting the numerator equal 0. So a little shortcut, if you want to find x-intercepts, just let the numerator equal 0. Okay, so let's look at this one. It's already simplified. There's nothing that I can factor or cancel out. So when I look at it from the previous section, I know the vertical asymptote is going to be x equals -3, right? Because that comes from the denominator. There's no holes because nothing canceled out. So that was from the previous section. Based on what we just learned about horizontal asymptotes, the degree of the top and the bottom is both 1. So the horizontal asymptote would be y equals the number in front. Well, in this case, the number in front on both the top and the bottom is 1. 1 over 1 is 1. Okay, remember up above we said the easy way to find x-intercepts is to let the numerator equal 0. Well, if x minus 5 equals 0, then x equals 5. So we're going to say 5 comma 0. And then remember the y-intercept is always 0 comma something. So look right here, isn't that the x coordinate? If we put in a 0 for x, so put in a 0 for x into your equation. Everywhere you see an x, you're going to have 0 minus 5 is -5. On the bottom, you have 0 plus 3 is 3. So that means the y-intercept is going to be at -5/3. Okay, so what are we going to do with that? Well, let's put it on the graph. So I always start by putting my asymptotes on. So I've got a vertical at -3. So I'm going to draw in this dashed line. Gives me an idea of my graph. Got a horizontal at y equals 1. Make sure you extend them way out, even beyond the graph if you can. No holes. I do have an x-intercept at 5, so it crosses the x-axis at 5. And it crosses the y-axis at -5/3. So that's going to be somewhere between -1 and -2. Okay. Now, how do I know what the graph looks like? Well, look at this equation. It's nothing that I know the graph of. It's not really the 1 over x graph because there's an x on the top and the bottom. But when you look at the graph, do you see that there is a vertical asymptote and a horizontal asymptote, just like the 1 over x graph? So that means the graph is going to be similar to the 1 over x graph. And I can see that it has to go through these points. So the graph is going to do this kind of thing. And I know what asymptotes mean. It means that your graph shoots straight down, right? And just like on the 1 over x graph, the pieces are always opposite each other. So if there's a piece in the lower right, there has to be a piece up here in the upper left. So that would be my graph. Okay, so look at example 2. Let's pick out all the information. First, I'm going to need to factor that denominator. So x minus 2, I'm going to have x plus 4, x minus 2. I think that'll work. That'll give me the positive 2x in the middle. So that means the x minus 2's cancel. And I think it's always important to write down what you're left with. So I'm left with y equals 1 over x plus 4. So I know there's going to be a vertical asymptote at x equals -4 because that's in the denominator. There's going to be a hole when x equals 2 because that's what canceled out. Remember, in order to find the y value, plug 2 in for x, and we plug it into our simplified version. So if I put in 2 for x, I'm going to have 1 over 6 for the y value. Horizontal asymptote, well, it doesn't matter if you look at the original equation or if you look at your simplified version. When you compare the degrees, you're going to get the same thing. So if I like to look at the original, I don't know why. So if I look at the original, I have a 1 degree, and then on the bottom it's a degree of 2. So the top is less, so my horizontal asymptote is y equals 0. Okay, for the x-intercepts, remember we said look at the numerator. Well, look at your simplified version. Is there any way that this numerator could equal 0? Well, no. If it's just a 1, if there's no x's, it can't equal 0. So that means there are no x-intercepts. And then the y-intercepts, remember, that's going to be when the x is 0. So if I put in a 0 for x, it's going to be 1 over 0 plus 4. All right, so let's put it all on. I've got a vertical at -4. Okay. I've got a horizontal at 0. So make sure you kind of show it right there on the x-axis. I have a hole at 2, 1/6. So 2, 1/6 will be just barely above the asymptote. So show a little hole there. It's not a point, it's like an open circle. And then I have a y-intercept at 1/4, so like right in here somewhere. Okay, so again, I see the 2 asymptotes. I know it's going to be the 1 over x graph, plus look at my equation. Isn't that a 1 over x? So, and I've got these 2 points, so I know it's going to be in the top right. So one piece is up here in the top right. Make sure you show it going through those points, right? It goes through that hole and on out. And that means the other piece is going to be in the opposite side, something like that. Okay, let's do another one. Look at number 3. We always start by factoring. So x squared plus 3, oops, what am I doing? X plus 3, x plus 2, I think that'll work. Hopefully you can see the x plus 3s are going to cancel. And so all I'm left with is y equals x plus 2. So that's my simplified equation. There's no vertical asymptote because there's nothing left in the denominator. There is a hole at -3 because that's what canceled out. Sorry about my dog going crazy. In order to find the y value, I'll plug -3 in for x in my simplified version. So -3 plus 2 is going to be -1. Remember the horizontal asymptote, you compare the degree, but the degree of the top was 2, the bottom is 1, so there are none. And if everything cancels out and there is no denominator, then it's going to be a none. For the x-intercept, remember you let the numerator equal 0. Well, in this case, the x plus 2 is the numerator. So what will make that equal 0? If x is -2. And then the y-intercept, remember you put in a 0 for x. If I put in a 0 for x, I'm going to get y equals 2. Okay, so let's put this on. There's no horizontal, no vertical. There is a hole at -3, -1. There's a hole right there. X-intercept at -2. Y-intercept at +2. Now, I don't see any asymptotes. How do I know what this graph looks like? Well, look at the simplified version of the equation. Isn't that like an mx plus b? Right? So the slope is 1, y-intercept of 2. And notice the points that you have, don't they all line up on a nice, neat line? So just draw the line that passes through those points. So I can get this kind of nice and lined up. Make sure that when you draw that line, you can still see the hole that's right there. So there's the graph. Okay, so let's go one more example. First, we put it in factored form. So I'm going to factor out a 2x. All right, 2x leaves me with x plus 5. The denominator, x plus 5. x minus 5. So the x plus 5's cancel. So we end up with just 2x over x minus 5. All right, so vertical is the denominator, so x equals 5. Whole at negative 5, because that's what canceled. And remember, in order to find the y value, you plug negative 5 in for x into the simplified version of the equation. Here's my simplified version. So if I put in a negative 5 for x, on the top I'm going to have negative 10. And on the bottom, negative 5 minus 5 is negative 10. Doesn't that just simplify to be 1? Negative 10 over negative 10. So 1. Horizontal asymptote, compare the degree at the top and the bottom. Do you see that the degree is the same? Again, it doesn't matter which version you look at, the original or the simplified. The degree is the same. So if I look at the coefficient, the leading coefficient is going to be 2 over 1. So horizontal asymptote, y equals 2. X-intercept comes from the numerator. So what would make this numerator equal 0? Wouldn't x have to equal 0? And then the y-intercept, we know that the x-coordinate is 0. So if I plug in a 0 for x, don't you get 0 over negative 5, which is 0? And hopefully it makes sense. If you have 0, 0 as an x-intercept, it has to also be a y-intercept, right? Because isn't the origin, doesn't that go through both the x-axis and the y-axis? Okay, so let's look at the graph. I've got vertical at x equals 5. So vertical asymptote, x equals 5. We have a hole at negative 5, 1. So right there. Horizontal at y equals 2. And just the fact that I have both a horizontal and a vertical asymptote makes me think of the 1 over x graph. And I know it goes through the origin at 0, 0. And because of the points I have, I can see that it's going to be on the lower left. So I'm going to draw in the shape that I know the 1 over x graph shape does, right? Something like that. And then it has to be on the opposite side as well. Okay, so hopefully that helps with actually putting together the graphs using all of the asymptotes.